Hello, I am Jae-hee Lee, the head instructor of Lee's Science Academy. This channel logically and systematically delivers the fundamental knowledge of natural sciences that is highly recommended to acquire before starting your major studies in college. This is not a lecture focused on simple memorization. In short, it is a channel for true learning. Of course, it will also satisfy the intellectual curiosity of the general public who wish to systematically understand natural and life phenomena. This channel is produced and provided in South Korea. The narration is delivered using the voice of Iapetus, an AI model from Google Cloud. I sincerely thank you for visiting this channel, and I hope you find it helpful. Thank you. Today, we are going to study natural numbers within the number system. There are various objects of study in mathematics, right? The most important among them is the number itself. We call that subject mathematics. As our first lesson on numbers today, we will study natural numbers. Here are the main topics for today's lecture. We will explore how the process of abstraction, which is the creative process of making numbers, is carried out. Starting from the number 1 to 2, 3, 4, 5, 6, and so on, we will examine the process of creating all natural numbers. We will study what kind of relationship exists between each natural number, focusing on the structure or system of natural numbers. We will also learn about where and how these created natural numbers can be used, focusing on the functions of natural numbers. Finally, we will examine the property that numbers are unitless because they are abstract entities. Here is the real number system. Looking at the structure of the table, natural numbers 0 and negative numbers combine to form integers. Integers and fractions combine to form rational numbers, and rational numbers and irrational numbers combine to form real numbers. After we generate all the numbers up to real numbers, we will also study vectors and complex numbers as extended numbers. Today, as our first step, we will study how natural numbers, which appear at the very beginning of the real number system, were created. Numbers are not created randomly. They are formed through a cognitive process called the process of abstraction. To truly understand numbers, you must fully grasp this process of abstraction. The process of abstraction for creating numbers is probably something you are hearing and learning for the very first time. It might feel difficult because it is unfamiliar, but in line with the motto of this channel, I will explain it logically and systematically. If you follow the lecture, it will be easy to understand, so please stay focused and follow along carefully. Before we dive into the lecture, let me ask you a question. We have been learning mathematics for a long time, but can you answer the question, what exactly is a number? It is not an easy question to answer. After listening to today's lecture, you will be able to answer what we call a number, and what a number truly is. From now on, we will examine how the process of abstraction creates numbers. I have linked a video in the description below that explains the process of abstraction in detail through a humanities lecture, so please watch it if you have time. If we define the process of abstraction, it is the cognitive process of creating something solely through thought in the mind. The wording might seem difficult, but you will understand it as you continue listening. The cognitive process of abstraction consists of 3 steps. The first step is the conceptualization step, where we make distinctions. When an object is given, we observe it closely and capture its unique characteristics. Using those characteristics, we find differences or commonalities with other things. Here we have a chair and a desk, Looking at them, we distinguish the difference well, noting that a chair is for sitting, and a desk is a table for placing things like books. Even in everyday life, when someone tells you to grasp the concept of an object, it means to find its characteristics. Also, when we criticize someone for having no concept, it means they do not understand something well. The second step is naming. We give names to distinguish the conceptualized objects from others. Chair and desk are the names of the objects. Fundamentally, names are expressed through speech, not writing. In the third step, the object or name is expressed as a symbol. Letters like English or Korean can also be considered a type of symbol. When the process of abstraction is completed like this, the resulting abstract entity consists of three things: the concept from step 1, the spoken name from step 2, and the symbol from step 3. If we apply this to a chair, the concept is an object for sitting, the spoken name is the word chair, and the symbol is the written word chair. Do you understand the process of abstraction? The process of abstraction is very important, so let's take another example. Two objects, an apple and a banana, are given as objects of perception. The human cognitive system finds the characteristics that differentiate the two objects. This is the first step of abstraction, the distinction and conceptualization step. We distinguish the two objects by characteristics, such as the apple being red and round, or the banana being yellow and elongated. We gather all these characteristics, create a concept, and if we give that concept a name like apple or banana, we complete the second step. If there is a writing system, we express it with letters or other symbols, which concludes the third step. When first naming it, there would be no problem at all if we called the apple a persimmon or a strawberry. What matters is the concept, not the name. Makes sense, right? The human cognitive system can also perform abstraction on commonalities, in addition to finding differences. If we find a commonality, we conceptualize it, name it, and express it in writing. In the case of apples and bananas, the name for their common concept would be fruit. As you might have grasped by now, the concept distinguished in step 1 becomes the definition of the name assigned in step 2. When we call this name a term, the concept becomes the definition of the term. Here I want to tell you one really important thing. The point is that an apple and a banana can be distinguished because there is a difference between them. The difference between an apple and a banana allows us to distinguish them, and we easily understand their existence, recognizing that there is an apple and there is a banana. Thinking conversely, if there were no difference between an apple and a banana, individual apples and bananas would not exist. Only fruit would exist. The idea that something does not exist because it cannot be distinguished due to a lack of difference can be better understood using monkeys. As shown in the picture, there is a group of monkeys. However, if we cannot distinguish the differences between individual monkeys, we cannot differentiate them. Therefore, while monkeys distinguished by their commonality exist, individual monkeys distinguished by their differences do not exist to us. However, if a zookeeper closely observes the detailed characteristics of each monkey and distinguishes all their differences, they can be given names and distinguished. Thus we can say this: without difference, there is no existence. This proposition is true. Understand? Now pause the video for a moment and try the process of abstraction on various objects around you. I see a computer right now. I could define the concept of a computer as a device made of electronic circuits capable of high-speed computation and control. How is it? Do you understand the process of abstraction? Now, let's create the natural number 1 through abstraction. This is the process of creating natural numbers. Some people say numbers were discovered, and some say they were created. Please note that Lee Science Academy maintains the position that numbers were created. If a desk, an apple, a banana, a chair, and a monkey were presented one by one, what commonality would the early ancestors of humanity who first created numbers have found? As step 1 of abstraction, they grasp the concept of the number 1. It is a single item, or one piece. They are all different kinds of things, but there is exactly one of each. Understand? Have you grasped the concept too? Understanding this concept of 1 is the starting line and is very important. Next, they explain this concept to the person next to them by vocalizing 1. 1. They are communicating through speech. Then, although the companion goes through a very difficult process, once they understand what 1 means, as step 2 of abstraction, the spoken concept of 1 is established between the two people. Now, the two people can communicate the concept of 1 to each other using the word 1. As they represent this concept by picking up a single twig or drawing a horizontal bar or a vertical bar on the ground, they enter step 3 of abstraction, creating a symbol to represent 1. Finally, they have created the number 1. They have taken a monumental first step in human history. Please pause the video and carefully review the entire process. For humans who created the number 1, creating numbers larger than that was an incredibly easy task. For objects that exist in pairs, they create the concept of 2, name it 2, and for objects in groups of 3, they create the concept of 3, name it 3. For objects in groups of 4, they create the concept of 4, and name it 4. In this way, by continuously adding 1 to the previous number, they create the next numbers, 5, 6, 7, 8, 9, 10, and so on. You can understand that if you continue this process endlessly, you can create all the natural numbers, right? Please pause the video for a moment, review the creation process of natural numbers, and make sure you understand it well. Let's look at the structure or system of the natural numbers we just created. As clearly shown in the creation process, natural numbers were made by adding 1 to a given number to make the next number. Adding 1 to 3 makes 4, and adding 1 to 4 makes 5. Natural numbers have a number system that starts with the smallest number and continuously adds 1. Please understand this point well. In the future, we will prove that a given number is a natural number by showing that it possesses this property. If we set 1 as the smallest number and start from 1, we can create natural numbers greater than or equal to 1. If we set 3 as the minimum value, we will be able to create natural numbers greater than or equal to 3. This system of natural numbers becomes the logical foundation for a method of proof called mathematical induction, which we will learn later. So you must understand it well. When we cover mathematical induction, we will also study the Peano axioms, which established the system of natural numbers. Let's look at the 3 functions of natural numbers and how we can use them. Natural numbers act as counting numbers or cardinals. As clearly shown in the creation process, they are used to count the number of objects, like 1, 2, 3. Natural numbers can also be used to establish order. These are ordinal numbers. Since natural numbers are created by adding 1 at a time, they can express order according to the sequence in which they are made. 4 comes after 3 and before 5. The ordering function can be seen when lining up in class according to student number order. Another function of natural numbers is that they can be used as identification numbers or nominals, which replace or represent objects. Player number 7 of Los Angeles FC represents the player's Sun Hyung minimum. The smartphone number you use is also an identification number that represents you. The logical law of identity was applied to the judgment that player number 7 is Sun Hyung minimum. Please refer to the recommended lecture below for more on the law of identity. Before we end the video, I want to emphasize something you must never forget at this point. That is the abstractness of numbers, and the property that numbers do not have units. As clearly shown in the creation process of natural numbers, numbers do not actually exist in reality like desks or chairs. They were created in the mind. This means that numbers were created as abstract entities. Numbers are a means of expressing the common property found in various objects we discussed earlier, such as apples, bananas, chairs, desks, and monkeys. Although they are all different kinds of things, the single concept of number is common to them all. Numbers, which express abstract concepts, do not distinguish between objects. They only express the concept of number itself. This is a very important proposition. Please engrave this in your mind. For example, even in a situation where a chair and a monkey are together, although they are different kinds of objects, we can still find the number 2. Even in a situation where a monkey and an apple are placed on a desk, we can find the number 3. If you want to distinguish and express objects, you need to abstract the content you want to distinguish, and then you need a symbol related to that distinction. We call this distinguishing symbol a unit or a counting unit. To distinguish and express objects such as 1 apple, 1 monkey, or 1 bunch of bananas, we need specific units like pieces for apples, animals for monkeys, or bunches for bananas. The fact that physical quantities used in natural sciences have units also provides the function of distinguishing one physical quantity from another so it can be expressed as a number. Numbers do not distinguish objects, but to distinguish objects, units that represent the objects are required. Makes sense, right? As a result, 1 chair and 1 monkey can be combined to make the number 2, because the numbers themselves do not distinguish the objects. However, 1 apple and 1 monkey cannot be calculated together, because they specifically designate and distinguish different objects. This property is the reason why, in physics, you cannot add length and area, and you cannot add force and energy. This is very important content, so please understand it well. So far, we have examined the process of first creating the concept of numbers through abstraction, and then creating all the natural numbers. We also understood the system of natural numbers, creating the next number by adding 1 to the previous number, and we explored the functions of numbers, where natural numbers are used as cardinals, ordinals, and nominals. Finally, we understood the property that, due to the abstractness of numbers, numbers do not distinguish objects and do not have units. Now, can you answer what a number is? In the next lecture, we will learn about the operations on natural numbers, how to calculate using the natural numbers we have created. This concludes today's lecture. Thank you.